So either I can drive them and you tell me next slide, or if you have the phone login here, you can. There's a button that's like the document, and you can request to share slides, and you can pick your slides, and then you can click through them yourself on your phone. That's fine. Either way, I don't really care. That microphone on the pink X, because then the camera will look at you. Yeah. Yep. I'll call you up. Yeah. Yeah. Exactly. And the cue for that is using the little phone thing to raise your hand in that, and then you get in that mic line. So questions come from that mic, and the presenters have this mic. Well, the chairs are Mark too. No, Mark is virtual, but he is virtually here now. Hello, Mark. Yeah, absolutely. Hey, Mark. All right. The room is still relatively empty. We're coming out of lunch, so thinking we could give it a minute.
What's with the big bell?
So we're in this city called Philadelphia, and they like big bells here.
So
Broken ones. They break their bells.
On one
Sort of like
side, we have the
Vienna.
big bell. On the other one, we have the big floating head.
So they're careless.
Yeah, let's make sure to not drop the ladder.
While we are waiting, we have a poll that you can participate in. Brutal. Oh, we can't hear you, Mark, for some reason.
No?
There we go. Now we can hear you.
Okay. It's a very tempting end session button that popped up with that.
Sorry. Okay. How do I end the thing? No. End session. All right. Okay. Do you want to get started, Mark? What do you think? Yep.
Unmute?
Uh-oh.
No.
Uh-oh.
Did it unmute? No.
Oh, he's back a little bit, yeah.
The latency on my microphone unmuting is very high. I think this one's on you.
So Mark, I've had a good experience with just keeping the mic on and doing a local mute for these things.
Am I muted now? No. Okay, that mute button doesn't work. Hold on.
Yeah. Alrighty. We do have a tight agenda, so let's get started. welcome to the meeting of HTTP at IETF 114. I think this is the first semi-in-person meeting at an actual IETF meeting we've had in a while. Thank you everyone for all of your attendance of the various virtual interims we've had. We've made a lot of great progress, but it's also good to see faces here and on MeetEcho. And hopefully we continue to make good progress today. As you have almost certainly seen many times this week already, this is the Note Well, which describes the requirements for participation in the IETF and creating contributions to this and other working groups. Do make sure you are familiar with it. Also, in IETF, we have codes of conduct and general rules of trying to be civil and friendly to each other, and this is a great group at doing that. So, as we are going through our work today and hearing about some new work, let's make sure that we are welcoming to it and give good constructive feedback. And then also for the people who are on site, masks are required. You do need a KN95 equivalent ... mask. If you don't have one of those, you can get them at the registration desk. All right.
And if
Moving
you're,
forward, yep.
sorry, if your
Please.
experience of this group is not that it's a great group for that, if you've ever experienced harassment or you feel like it's not a great environment, please do talk to Tommy and I. We do want to make sure that it's a good experience for everyone. And if you're not comfortable doing that, there are other resources for you as well.
Absolutely. Yeah, thank you. All right, so here's our agenda for today. We are currently in the Administrivia. We have several active drafts that we're going to get a catch up on, along with a summary of a side meeting that occurred earlier this week. And then we have 4 newer proposals that are not things that we have adopted into this working group, but have been discussed on list. So if you have any agenda bashes, please let us know, but then we also will need a note taker. Can anyone volunteer to help take notes for this session? Mike Bishop wants to volunteer.
Not quite, but if I'm going to be talking to alt service and the origin frame, could we just flip the origin frame to be up next to alt service?
That seems reasonable to me. Any objection, Mark? Or that's fine. Yeah, fewer going up and down the stairs. Eric, you'll take notes? Thank you for taking notes. I appreciate it. Does anyone want to officially jabber scribe? Thank you, David. Great. Let us begin. Anything else, Mark, before we get into it? Great. All right. I'm going to switch slides to go to the slides for the summary of the side meeting on alt service. Mike, do you want to talk us through this? Oh, did you want us to share it? Yep, you can do it.
Now let's see if I have
Yes.
Okay. So, key takeaways from our side meeting yesterday.
Or pick it up.
Yeah, I think I just need to pick it up. Yep. Any better? Let's try this. Okay. I'm not coughing to the mic. So, key takeaways from our side meeting yesterday. Basically, alt service is great for being able to narrowly tailor information to one particular class of users. But a lot of what we're using it for right now is really about protocol capabilities. You know, do I support H3? Do I support H2? Do I have multiple endpoints? And all of that can go in the DNS, and Service B, the HTTPS record, does a great job for that. We should just use it. And the main thing that the server knows when you're talking to it is if it is not the right place for you to be talking, It probably is roughly right about that. So if you can't, if it's going for shutdown, it can't continue working, we already have go away in the protocol for that. We don't need anything for alt service. So what we're really trying to cover is the case where the server thinks it's probably not the best endpoint for you to be using, but it's willing to continue serving your requests if you need it to. We want some degree of stickiness there. We want that recommendation to last until the network changes or the server config changes. Now, part of the problem we have with alt service today is the client only kind of knows when the network changes, and the client does not know when the server changes. So how is the client supposed to clear its cache based on those events? But if you just say it's not sticky and you have to get told every time, then you wind up bouncing. I ask the origin, it says go over here. Next time I go back to the origin, it still says go back over here. And bouncing is not good either. So, and this is the fault in putting my phone away. So the key idea here is not exactly going to spell it this way, but all we really need is a host name, or more precisely, a DNS label. If we're saying everything else should be in the DNS, then we just need a pointer to where we find that stuff in the DNS. So what you might do with a single host name is, for this connection, go do an HTTPS resolution, almost as if you had found an alias mode record from the origin to that name. Do your alternative selection and connect based on the results from that lookup, just like you otherwise would during a connection. And if all of that works and you wind up with a usable authoritative connection, go use that one instead of this one. And then for the stickiness, we're thinking something along the lines of, remember the service mode names that you found when you did that resolution. When you go to connect next time, if there's some overlap there, if you find that any of those are still valid based on the regular origins records, go use it. And if you find that there's no overlap, probably something has changed, drop your cache and just believe what DNS told you about this origin. Now, going to actually integrate this with alt service as we have it, there are a lot of different ways to spell it. We have an alt service bis that's already been adopted here. We also have retrofitting the alt service frame as part of that. Do we stop doing that work? Do we build something entirely new and adopt a draft there? Or do we try and shove it into alt service as it currently exists? We could hijack an ALPN value to serve as a sentinel. Something like use this one equals the host name we care about. Or we could be really crazy and just drop a host name in the alt service field. It will parse as invalid to any current parser, which in theory should ignore it. Nothing could possibly go wrong with that plan. But regardless of how we spell it, this is the direction we feel like we're headed. That does not necessarily mean this is committed, but we have documents in which we could do this work if we agree on what it should look like. So probably what we're going to have is some ideas that bounce around on the mailing list. We might wind up with a design team or discussion in an interim, and we'll go from there.
Alrighty, David is in the queue.
David Skenazy, HTTP header enthusiast. I apologize. First off, I want to apologize for missing this side meeting. It happened to conflict with sleep, and the sleep working group had to be prioritized. Sorry about that. It seems like what this is saying is that the use of quick is dependent on the HTTPS frame now. Is that a correct understanding? Sorry, on the HTTPS resource record in the DNS.
Yes, that probably would be the result.
If the only way you learn about it is dynamically.
Which is how that works today on the web, right? Yeah. No. So unfortunately, most OS APIs don't let you query HTTPS resource records. I know the Apple one does because they're on top of things, but Get Out Our Info doesn't, for example. And there's no POSIX equivalent that does this. I couldn't do this for Chrome because while we're trying to move all deployments of Chrome to use the Chrome's custom DNS client, which does everything itself, that one knows how to query for those records because we're also on top of things. But we can't use that on all OSs, especially when there are OSs where things are complicated, like there's a VPN, and we say, okay, screw it, this is too hard. We fall back to Get Out Our Info. And then we would lose quick. So that would be a non-starter for us. I would say, I would love to be part of this discussion because I think that's an important feature for us. Even though I love the idea of putting everything in the DNS here, I don't think short-term it's necessarily the right plan.
I think that's a really good point about compatibility in the short term. I think that almost sounds like an argument for being able to shoehorn it into the existing alt service, such that you could just say, I'm going to also include some legacy alt service entries, and I accept the problems if I have to use one of those, but if I'm on a platform where I can't query service B, that's what I got to do.
That could be a good solution. Thank you.
All right, Martin, and I think let's move on after this since I think
okay.
we'll need a design team discussion.
Yeah, so Martin, Thomas, just briefly, I understand the implications of having to implement this on a vast number of platforms where DNS is, well, let's just say sketchy. But I think the future is bigger than the past, and we really do want to move people onto HTTPS records for HTTP. So I'd be somewhat comfortable doing this on the understanding that some people would not be able to benefit from it, and that's always been the case for alt service anyway.
Yeah.
All right, thank you.
So I think we're done with that piece.
Yep. Do you want to just share slides again?
I don't have slides for that one.
Right.
Basically, where we stand there is I believe, resolved the one open issue on the document.
Yeah, let's talk about which one.
For the origin frame. Origin frame for H3. I've resolved the one open issue that was on the document, which is addressing an errata from the original RFC. And unless anybody has any other issues, it's a pretty simple document. Are we ready for working group last call?
Does anyone have any comments on Origin H3? Any objections to moving it forward to last call?
Okay.
We got a thumbs up, no thumbs down. That seems pretty clear. Any thoughts, Mark?
I wonder if this potential work on the alt service universe might touch Origin, and if so, whether we should hold on to it just a little while.
Mike, if you have any thoughts, you can get in line too.
And it's certainly possible that we'll have a broader conversation about connection coalescing as part of that, which might touch Origin. There are certainly things about Origin that it might be nice to fix all up, but we had previously agreed not to try and change the semantics of Origin, just to port the frame over. So.
Right. Yeah, so we could adopt another document to do that.
David Scalazzi, another option would be to do the working group last call. I think that would be useful because it would get everyone to read it and then park it there. Don't send it to the IESG. I mean, that tells us that barring any major news that come about service, this will go forward, but it's not open season. Like the working group last call already happened. This is pretty much done in the other case.
I actually, for a limited time, I think that makes sense. Just maybe until the interim or something. Okay.
Great. Okay. So moving right along, I believe cookies is next. So Stephen, if you want to come up.
Guess I'll just hold this. All right. Hello, HTTP Working Group. I'm Stephen, and I'll be giving a quick update on RFC 6265bis and its progress. So since the last, next slide, I'm not in control here. Since the last interim meeting, there's been another draft published, 10, that had the following changes in it. Did some stuff with around max age, opinions around privacy, some other things. We've also closed out several more issues since then, working towards getting us down to 0 in-scope issues. Oops, next slide, please. Yep. All right, I'll get this right. There you go. Thank you. Closed several more issues since then. Don't think there's anything up there I particularly want to call out. Next slide, please. As for the current issue status, we have 4 open issues. I've split these into 2 parts. Currently in scope is issue 2185 named Cookie Octet Reality Check. The one sentence summary of this is that the spec's current structure is confusing and prone to incorrect implementation, specifically around UAs that are accidentally implementing the more strict server syntax rather than the more permissive UA requirements. The next issue is 2104, same site cookie and redirects. A little while ago, the spec was updated such that same site needed to take into account redirect chains, with every site in the chain needing to be same site. Both Chrome and Firefox attempted to implement this and saw a ton of sites break. So we've backed it out, and now we're trying to figure out what to do with it. Under the maybe should defer, this is my opinion. We have 2 here, parser for domain attributes. This is more of a spec technicality in that there's a little bit of a hand-wavy section where a sub-algorithm says, if this is an IP address, then behave a certain way. It never specifies how you should tell if it's an IP address. I don't think that's worth blocking 6265bis on. The next one is that the parsing algorithm should enforce more of the syntax requirements. This comes back to the more strict server syntax that I mentioned earlier. This issue is interested in having UAs enforce that stricter syntax and kind of rein in the more permissive one we're using right now. Finally, there's about 14 additional deferred issues that are not in scope for 6265bis any longer. Coming back to the in-scope issues, I just want to talk a little bit more about those. 2185, one of the proposed changes for this issue is to merge the UA and server syntax. That is to say, allow servers to create cookies that adhere to the more permissive UA requirements rather than their existing more strict requirements. An alternative proposal is to keep the syntax as is and instead edit or rephrase the relevant sections to make it less likely to accidentally implement the wrong thing. Pardon me. If the consensus is the former, merging the syntaxes, then I suggest that this issue be deferred because that's a very significant redesign of the spec. If the consensus is the latter, the rephrasing, then I think that's probably in scope for 6265bis. And then for 2104, the redirect, we're currently considering this a blocking issue for 6265bis. Unfortunately, we don't have too much information on how to solve it yet. It's still under active investigation. But looking forward, once we resolve all these in-scope issues, we're hoping to proceed to working group last call. All right, that's it for me.
All right, thank you. And we have 2 people in queue. 3 people in queue. Martin, start us off.
Yeah, just a simple comment. 1939 there, I think the what working group spec on determining the difference between in the URL spec has a pretty simple set of rules for distinguishing between domain names and IP addresses. I put it in chat what the regular expression looks like. It's pretty straightforward to explain even. So I would suggest that we just pull in a definition either by reference or write it out. It's probably 1 paragraph.
Oh, okay. Yeah, great. I'll take a look at that.
Would you mind dropping that in the GitHub issue too?
I was planning to do that, yes.
Thank you so much. All right, Ted.
This is just really a clarifying question. When you say that you thought merging the syntax would be essentially a great deal of work compared to rephrasing, I was wondering, has anybody taken a run at it yet so that you kind of know how hairy it is, or is this your impression from eyeballing it?
So what I meant by work was not so much changing the spec itself. It's more that it has the potential for a lot of side effects that we would need time to sit and see how that actually planned out rather than going ahead and moving into last call. I'd really feel better if we did that the spec had time to sort of like wait and see for servers to actually implement this new syntax and what the results could be.
Thanks for the clarification.
Mark.
Okay, I'm a little confused then, because the proposal that I made, full transparency, was to use the obs text construct from HTTP core, which does exactly what's being talked about here. It effectively obsoletes a particular range of characters, so that I don't think it would have any impact on implementations. It is just an editorial change. And I'd be happy to do a PR for that, or at least attempt one, if that's the issue.
Yeah, I did see your change, Mark, and I'm happy to talk more offline. My big concern there was we've had evidence in the past of implementers just kind of skimming the spec and implementing whatever looked right. And I'm not 100% confident that they would understand or they wouldn't understand what the obsolete is. They'd see a grammar and they would implement it.
My experience is that if the goal is to defend against people who don't read, there's very little we can do by writing things. I think that alignment with the core specs would have a nice property of, reducing the amount of new stuff they have to understand.
Yeah, and I said this in the issue, but I like your idea more. I'm sorry I didn't list it in my alternate solutions, and that's what I'm open to discussing.
Okay, let's chat.
Okay, sounds good. But overall, it sounds like we just need to come to agreement on these last few issues and then hopefully move along soon. Yeah, thank you for the work.
All right, thank you.
All right, I think next up, Mark, we want to go through retrofit?
Sure. So we basically have one issue open on retrofit, which is the date format, issue 2162. And the heart of this issue is basically, excuse me, whether we take this opportunity, since we're retrofitting the date header, last modified, expires, which all contain dates, retrofitting a new structure type in so that they present in HTTP 1.1 or they present in any kind of textual representation of the structured header as something human readable and human friendly, or whether we keep the notion that we currently have in retrofit of converting them into an integer and conveying them presenting them as an integer. So, second since the epoch, which most people have trouble reading. I see both sides of this argument. I think that if I can try and characterize them, if having a human-friendly presentation is better for developers doing debugging, it's easier to make sure that it's presented correctly in tools, whereas a integer representation is, at least in the textual form, easier to parse and less overhead to parse. I'm of two minds, because in my mind the long-term vision for this is we have a binary representation of these structured types, and therefore the parse overhead isn't an issue. And there I can see the argument more clearly that having a developer-friendly representation is a nice thing to do. What I think it comes down to is that if you have tools presenting your messages, and they understand that a particular header has a particular type, then it doesn't matter whether we have a special type or not. They can say, oh, look, I know this is expires. I know that that's a date. Look, there's an integer, but I'll show the user a human-friendly date to be nice about it. The problem is that if they don't recognize that it's a date, then you can see the integer. Whereas if we have a date type, then it can be automatic. You can have a tool that does the right thing, and it's hidden from the user, and it happens for all dates, not just the ones that it happens to know about. I think that's what it comes down to. There are some concerns about if we don't ever have a binary structured types, which of course we don't, don't have anything adopted yet there, and we don't have any market adoption there yet, of course. Then we're stuck with the textual representation, which does have a little bit more overhead parsing, that does have a little bit more overhead on the wire. I think it's, we just use the ISO format. But I think we do need to make a decision, because this is our one opportunity to get it used for, if we do have a date type, to get it used for, the headers we're covering here. There's also a discussion in HTTP API about headers that they're minting that might have dates in them, and this is our opportunity to kind of get those to using structured fields properly. That's where we're at. We've gone back and forth. I'd love to get a sense of the room of what people think. Otherwise, I think we just need to take it to the list and hammer it out, but I'm not quite sure how we get to consensus here.
Sure. All right. Can people get in queue to express any opinions on this? Arton, I knew you were going to do it because I saw you fiddling with your phone.
Yeah, that's how you tell. So I tend to think that the machine readable thing is probably where I would head, the integer. Not just because I like the ease of processing of that sort of thing, but because even the dates aren't particularly helpful in a lot of cases anyway. I have to deal with time zone changes and all that sort of thing often, and it takes me 10 minutes to work that out, and the tools are better at that sort of thing anyway. So I do like the idea of having an explicit date type. I think that part is good, and having an indicator there that a tool can pick up on is pretty valuable. If we do go for the other one, I don't really care that much. I mean, I'm not completely bent out of shape if we go for a profile of the profile of ISO dates that's in 3339. The whole date thing is complicated. We don't need to do the full spectrum of options here. So it could be quite simple.
Sorry, Martin, just to clarify, you said that you want to go the integer way, but you also want a date type.
No, I prefer the integer way, but if we have to go the date type, we can very narrowly profile it, and it would be accepted.
That's what the PR does, I think, yeah.
Great. I got in queue just as an individual. I would agree with Martin that it seems to be simpler to do the integer. Also, if we're thinking forward to when we do want the binary representations of things, I imagine layers will need to be at some point converting potentially between a version of HTTP that can do binary and a version that is H1 or H2 or H3. And it seems like it is going to be a more deterministic and less buggy transformation to go from an integer to an integer than try to make sure that the leap seconds are always accounted for correctly and you don't end up bumping your numbers around accidentally.
Oh, so just to be clear, right now the proposal is not to account for leap seconds. Though, yeah.
Sure, but we can avoid the question entirely if it's an integer, right? Yeah.
Okay. I'm happy to go with using an integer. I just want to make sure we're doing that aware that consumers like HTTP API will probably just go back to using string headers, not structured headers. And as long as we're okay with that.
Justin?
Yeah, I don't have strong feelings about this, but I do think that it is more developer friendly to have a string-based representation that is vaguely human readable. Yes, I understand that not everybody, especially me, can do time zone calculations and things like that, but it is much easier to, say, compare two values, at least, speaking anecdotally, that are date strings as opposed to very large integers, trying to figure out what the difference is between those two. Again, as a human and as a developer. I'll also point out that this notion of having it be an integer in the underlying data model and having a string representation matches what the rest of structured fields kind of do. So Boolean, for example, it's a question mark 1 or a 0, but underlying that is it's a single bit for Booleans, and so it just, to me, it feels better to define it as an integer data model, but with a string representation with a clear format.
And by the way, just so people know that that's what the PR does.
Mike.
So looking at the PR, it seems like what's actually sent in the header is the date string, correct? I mean, not the fully expanded one HTTP uses now, but a string with year, month, day.
In the textual representation, yeah.
Yes. Is there possibly a midpoint where we represented it as an integer, but just give it a different character to mark that this field is a date and should be rendered as such by tools?
I think that's what it would be, yes.
We could do that.
Like an
Yeah,
at.
no, that's
Sorry, flow control.
uh,
We could do that. Personally, if we believe that binary structured headers is eventually going to be a thing, which I'm still on the fence about, but I like to live in hope, then that's kind of, that would give us a wire representation that is the integer, which has those nice properties. But it gives when you convert it to something that you need to show to humans, or you're in Wireshark or whatever, then you get the nice human readable properties, which, what I'm getting from the people who are kind of using HTTP rather than implementing HTTP, I get that that's a really nice property from them. And what I'm concerned about is that, if it's a really unnice property, a representation for them on the wire, or at least, in tools, then they're not going to adopt.
Okay, any other feedback? Eric.
Eric Kinnear, Apple. I would say that we provide some tools, and there are a lot of other tools that we don't provide, but at least in many of the tools that the Apple ecosystem uses have lots of places where there's something that is ugly, and I say that with quotes, for humans, but makes a lot of sense for a wire format. And we're pretty used to saying, hey, nobody wants to look at this massive integer and try to determine if that's yesterday or 3 years ago. So it seems reasonable to expect that anybody who sees that integer is going to instantly be looking for a way to make sure that their tool shows something that is useful for a human.
Okay, any other comments? Or Mark, what do you need to make progress on this? Anything
I just
else?
need to make a decision.
So-
I'll take it to the list again, I guess.
I mean, it does sound like no one would, not be able to handle either case. Like, it seems like there's no blocking opinions in either direction. I guess if there is a blocking opinion in either direction, please speak up now. But they all seem to be preferences for what is easier, and different people have different perspectives on what is convenient for them.
One thing I might do is talk to HTTP API and and show them the PR, and if they indicate that they would, at least look at it for future fields, then that's good information. If they're not interested, then maybe there's less of a point.
All right. Anything else? It sounds like David Benjamin on the chat was strongly preferring the integer with an @ in front of it. So cool. Okay. Should we move on from the retrofit, Mark? All righty. Next up, we have signatures, and we do have slides. Justin, did you want to share your own slides? If you just do, they should be preloaded, so you should just click the share preloaded slides button.
Sure.
And that will grant access.
Share slides. Here we go. Signatures. And share those. Okay. Those should be coming through. All right, fantastic. All right, so update on message signatures. My name is Justin Richer. I think I saw Annabelle in the participants list as well, so she can type in as needed. So I'm not going to go into depth on how this all works because we've presented this a bunch of times, but basically it's a detached signature mechanism for HTTP messages designed to work across HTTP versions and in all of sort of the weird kind of chopped up ways that HTTP kind of exists out in the wild. And this is for applications that really can't rely on whole message encapsulation like you would get with something like OHI or anything like that. So the way that it works is that you take the HTTP message and then you generate what's called a signature base using a set of rules that determine how you take content from the message and put it into the signature base in a deterministic fashion. And then that gives you your signature output, which consists of both the list of things that got signed and the signature itself. You send both of those as message headers, and that is how you get a signed message. Now, the message component, we had to invent a bunch of terminology for this, and I'm going to be using that throughout the presentation. Yes, Julian Fields, not headers. Sorry. I work in the sec area. So I appreciate the keeping that honest. Yes, these are fields. Anyway, this is an example message component, which in this specific example is a dictionary field. And this is a dictionary formatted structured field in this example. And the bits that make this up are the component name, which in this case is the name of the field, dropped to lowercase. The component identifier, which is the component name and any parameters that are attached to that particular instantiation of it. So in this case, we've got the name and the particular key pulling out a single value from that dictionary, and then the component value, which, because this is a dictionary field, we can pull out a single value and sign only that without signing the rest of the structured dictionary. All of that gets added together for one line in the signature base. Now, this is an example from a field and sort of a more esoteric example to show what the parameters and stuff look like. But there are message components that are also based on sort of the larger context of the message. So you can sign the things like the method and target URI for a request, or you can sign the status code for a response, all sorts of stuff like that. All right. So the signature process is that you take in the message, your key material, the things that you're required to sign, you run that through a crypto primitive, and then you get back out your message signature and signature parameters like I was showing before. The verification process is you take in the message and those parameters, and then you regenerate that same signature base on the new context of the verification process that the verifier has. Since HTTP messages can be transformed in a bunch of expected ways on the way through, this is where this process really kind of starts to shine, and that a signature can be robust across those transformations. All right. So what have we been up to? We've added a few more security and privacy considerations, how to deal with weird stuff like setCookie, which doesn't behave like other HTTP fields. We've clarified how this relates to the digest draft, which we'll be hearing about, I think, later today. And most of what we did was just a lot of cleanup, clarifying those terms that I was just using, making sure we're using the right terms throughout. We expanded our examples. The two functional changes that we are sort of additions for advanced cases. So the REQ flag, marking something as a request response. So when you're signing a response, you're signing it. Oh, thanks, Lucas. No. So when you're signing a response message, it's always in the context of some type of request message. So you can actually sign parts of the request and include those in the response. And this is being used for non-repudiation in a few applications of this out in the wild. We also added the byte sequence flag, mostly to deal with problematic fields like setCookie, which don't follow the list syntax and could be used to leverage some very esoteric but still possible attacks against this. So when you're doing things like setCookie, you binary encode it basically, and then wrap that into your signature that way. This has been being implemented all over the place. A lot of people are taking their updates of the old individual drafts, especially the cabbage drafts that were floating around as an individual draft for years, updating them against what's new from the working group. This is just the list that I personally know of. I know for a fact that there are more out there because I get people poking me about this from time to time still. But we're seeing people actually building and importantly using this, and that's been really, really good to see. I would like to pull these libraries up to httpsig.org, which is just a site that Annabelle and I run for people to play around with signatures as just a bit of a resource on this stuff, but we haven't gotten there yet. We'll probably put those up at some point soon. I've also been presenting this work all over the place. I've got a talk that includes Tom Holland in drag. Unfortunately, this is not this talk today, but it is definitely an interesting way to talk to people about how weird HTTP actually is. So talk to me sometime if you want a pointer to that. The GNAP working group is making use of HTTP message signing as the primary signing and key proofing mechanism inside of the GNAP spec. So this is the GNAP Smurf for those that don't know. And so that is a direct reference to this work. In full disclosure, I'm also lead editor of the GNAP specification in that working group, but it's not a coincidence that these two things fit together well. An interesting one that I'm not directly involved in, but the financial grade API draft specification in OpenID Foundation is also referencing this, using message signatures specifically for data non-repudiation for API calls. This is not token binding specifically. It is, in fact, the API signing a response that says, no, really, this is the response to that particular request, and you can prove it based on this signature. So a really interesting use case, a bit outside of what brought me into trying to define this stuff. But there we go. Httpsig.org is still up and running. It's been updated a little bit. Please go, feel free to play around with that. I actually generated the example at the beginning of this presentation using httpsig.org. So the tooling in there is pretty fun. And the Python library that runs the actual parsing and crypto stuff is sorry, I'll answer the chat question in a moment. The Python library that runs this is actually now published on PyPy. So you can pull down, I think it's httpsigpy is what I had to name it. And you can pull that down if you want. Clarification question on how it works. The normalized fields are not sent across the wire. They have to be renormalized by the verifier. What is sent, and I'll go back to this example, is you get a list of these content identifiers, and these give you enough information to recreate the signature base, as long as as long as those parts of the message that you're signing have not actually changed. So you do not actually send the signature base at all when you're doing this. Okay. So at this point, the authors believe that we think we're actually pretty ready for working group last call. The core has been stable for a very long time. The stuff that we've added recently has been mostly like refinements and corner cases and a lot of editorial stuff. We're seeing more and more implementations. We're seeing implementations that interop with each other. Other work is depending on this. And there's only a handful of issues that we think that are in the issue tracker today that we think we can close pretty quickly, either without action, just before working group last call, if we can get some good feedback, or as part of working group last call. And I was going to go through that handful of issues really quick here. So there's a couple of probably closable issues. I'm asking people to go read through those real quick. The editors are planning to just close those out with no additional action. We've talked about these before. It's just more of like a, please help sanity check this. There is a
I actually just closed one of those issues like 20 minutes ago. The
fantastic.
sign-specific cookies issue.
Okay, fantastic. I refreshed the issue tracker too early in this call then. So there's a proposal for something called signature context to be added. This is all written up under issue 2133. The editors have actually written pull request 2222 with a proposal to add an optional parameter with descriptions of use, but not require its use as the original proposal required or requested. Please go read through that. Editors are currently leaning towards what we have in that PR as the resolution to this. Issue 2134, we're not exactly sure what to do with cache if we need more text in there. There's some weird states things can get into if you're getting a signed response from a cache. Is that as meaningful? If you're responding to a signed request with a cached response, are there gotchas there that we should be aware of? We have some text in there. We don't know if it's good enough. We are not the experts to this, so please help us out with that, even if it's saying, hey, I read through things and it looks okay. And then finally, Lucas raised the issue of server push. We think that the way that we're defining message context for deriving all of the content is clear enough that server push messages in H2 and H3 should still be fine. But we just don't know. We'd like to get other people to take a look at this. So we think that these last two might need a little bit of text, might not. We just actually don't know. And that's all I've got. Like I said, we think that this is in pretty good shape and ready for, hopefully ready for working group last fall.
Okay, we have 3 people in queue. David.
Hi, David Skinazi. So thanks for the clarification. That was super helpful. This worries me because parsing HTTP headers or fields, if you care, yes, sorry, is super hard. Doesn't look like it actually is, but the number of security vulnerabilities we've seen in that space is astounding. Request smuggling, blah, blah, yada, yada, yada. In this proposal, we're signing a normalized version and sending a non-normalized version, which sounds like a recipe for a time of check to time of use problem. So am I missing something?
Yes. For the most part, you're assigning the header value exactly as it is sent across the wire. The field value is sent exactly across the wire. There are cases where you can opt into transforming that in specific ways. So there's one where it says use the strict structured field serialization definition. So if you know you have a structured field, you can say do that. There's the binary wrapping version, sort of with the BS flag. But for the and you have to trim white spaces and do the obs fold thing if you're in H1. But other than that, it is just the defined value. And for most developers, it's going to be take the thing that my library gives me off the wire and just chuck that in. And that works. So we're not normalizing the value. We're normalizing how they're stacked into the signature base. And we don't send the signature base.
Yeah, but any kind of normalization can lead to this problem if the unnormalized text triggers the vulnerability and the normalized one doesn't.
Yep. That is discussed extensively in the security considerations. And because you're not parsing the signature base to get values, it's not as scary as it seems on the surface.
Okay, I'll give that section more of a read. Thank you.
Thank you.
Jonathan.
We look at you with 1, 2, 3.
Very hard to hear you, Jonathan.
I cannot.
Oh, sorry. Let me create my microphone.
Much better already.
So can we just look at 2133, the signature context issue?
Sure.
Basically, so I think the optional is fine because it is effectively equivalent to just having it mandatory, but somebody could put null in or nil or whatever you want to use. But I would say that it's better to say mandatory, but you're allowed to put nil, because then at least you can be sure that all the libraries will implement it. Because if some libraries don't implement it, then it's not going to work. No one will be able to use it. So I prefer mandatory. You can put nil, but I don't think it makes a huge difference.
Okay. No, none of the libraries that I've seen are that strict about the parameters, and it's an extensible field set to begin with. So point taken. But what we've tried to do, if you look at the PR, what we've tried to do is instead say that if a specific application requires it, then that needs to be enumerated as part of the application of signatures. which I think should help that.
Yeah,
I
I think it will be secure, so fine.
I would be more worried about the confusion on the part of implementers or of the developers using signatures, generating signatures, if they have to supply a parameter with no value, as opposed to just omitting that value. If somebody's out there building libraries that don't support an optional value or optional parameter that's defined in the specification, I mean, then they're out there building libraries that don't implement the specification. So I don't know how much we can be expected to tolerate that. Obviously, we can write a spec that encourages proper implementation, but there's only so far you can go there.
Lucas?
Hello. Hello. As the author of the server push issue, I don't think we need to faceplant on it. It's just more of an observation. In a prior life, I had a use case for this thing. I'm happy to contribute some text if we think any's needed. I would have done that earlier, but I ran out of time. I think what I'm looking for from the authors here is if a server generates a push request that doesn't validate the signature, what would the client that received that thing do with it? But we can work on this offline, but that's kind of the one question I have that I can't answer.
Okay, I do not understand that question enough to even start that, so we should have a conversation about this.
And last, David then.
Am I audible? It sounds like I'm okay. Cool. Hi.
Yes. Yep.
Yeah. So I guess first I want to echo what David Skenazy said about the normalization thing. Like we've seen in basically every cryptographic thing that uses signatures. Like whenever you have this complex normalization process, then there's a lot of room for if there's any property of the message that the normalization process drops, which by construction it kind of does. If that thing is ever read by any code downstream, that is a place for an attacker to change the interpretation of the message more than what you were intended to. Like even the obs folding thing, if the downstream code used an API that was sensitive to where the headers were split, which they morally shouldn't, but HTTP is a complicated format, that will result in a security vulnerability. I can kind of understand why you sort of went in this direction, because you want to sign a thing that got exploded into the HTTP serialization. And so maybe for some use cases you're kind of forced into this not secure mode. But for a lot of other cases, where you can get away with it, it's much safer to have the thing you parsed be exactly the thing you signed. So for instance, maybe take your message and encode it in this binary HTTP format and then sign just that. That was what we did early on when I helped the Sign Exchange folks design some of their formats, and that was one thing that we were trying to push for, that the thing that you signed is the thing that you parse, and that way there's no room for other unsigned input to get in. And I guess sort of related to where attackers can inject stuff. So I noticed you mentioned that there was a lot of signature parameters that can change how the signature, it looks like it impacts both the normalization process and just changes what is even signed. Is that just carried in a header that the sender just fills in however they like, or?
No, it is very strictly defined as this is an ordered set of identifiers.
Right. I don't mean, I don't mean the format. I just mean how do you receive it?
It's a header. It's the signature input header.
It is also included in the message that is signed.
Right. Exactly. It's also the last line of the signature base every time.
Yeah.
But that means that okay, so if it's included in the message, that probably partially limits this, but only partially, because so for instance, we've got the so whenever we have that. Sorry, let me finish. Let me try to rephrase.
David, just to interject quickly, since we are over time on this.
Oh, sorry. Yeah. Okay.
Definitely good. It sounds like both you and the other David, if you could do a thorough review of the document and send your thoughts to the list, because I think it also would benefit from, you taking the time to analyze what's in the text now and pointing out if you think there are still gaps.
Yeah.
Yeah.
In,
My main worry is that
in
like
particular, if you could point out where you're seeing, significant normalization of component content, component values, that would be
Right.
appreciated, because
Yep.
as a spec author, one of the things we've tried to avoid is any normalization of values beyond what is already just inherently part of HTTP, such as collapsing of multiple header fields
Right.
with the same header field name.
Exactly.
my main
So-
worry is
All right.
So
you have
if you can
baseline
call
is
out
like-
where you are
Guys.
seeing that and where that's concerning you, that would be very appreciated.
Yeah,
Hey,
we
guys,
can
okay,
take
let's
this
move on. I think we need to
conversation
move on.
offline so we can move on.
Thank you. Thanks for being excited about contributing to this document, and we look forward to your comments on the list and on GitHub. All righty. Next up, Julian was going to talk to us about query.
Hello?
Hello.
Hello. Okay, no slides and no progress since last time. Sorry for that. I looked at the issues today, and I think where we are and what's left to be done depends a bit on what people expect from this specification. If all they expect something that is similar to Post without side effects, then we can probably say this minor editorial tuning, we are done. If we are looking for something which introduces proper cacheability of query results, then more work needs to be done. And I believe every time we look at these issues, we get into the, in a working group session, we get into the details, and it's really not simple to define these things properly. So I believe that we actually need a small design team to have 2 or 3 video sessions to come up with a concrete proposal to how to close these remaining issues. Feedback appreciated.
Well, I'd be happy to help.
So I try to summarize this on the mailing list and then invite people to volunteer, and then we can try to find a time slot in the next few weeks to talk about this.
Do we want to get volunteers here signed up?
Sure.
I mean, Mark, you already volunteered. Can we get any other volunteers? But we should also check the list. But anyone else who would want to help burn through the remaining query issues?
It's pretty clear that we need Roy, or that we should have Roy in that discussion. But he's not here today, right? So on the upside, I just bought you 10 additional minutes for other stuff.
Thank you, Julian.
Okay. Alrighty. I guess we can move on then. And we got some comments in chat, I think, that apply to this about providing feedback. Okay. I think that takes us to the end of the active adopted drafts that we were going to talk about today. And now we're on to some other topics that were proposals. So I believe Goye is next up. Did it work? No? Press the thing. Okay.
Hi, I'm Guoye. We are bringing our draft to the work group in the hope of standardizing resumable upload. Resumable upload is the ability to resume an upload from where it's interrupted instead of restarting from the beginning. Today, RFC defines resumable download, but not resumable upload. These sets unfortunately led to multiple incompatible implementations and protocols that are built on top of HTTP. To give you a brief bit of history, TUS is one of the most popular resumable upload protocols, and it has been widely deployed since 2013. Here is how it works. To start an upload, you use a zero-length post request to retrieve a unique URI that contains a server-generated token. Then you use patch to start an upload to that target URI. In the case that the upload is interrupted, you can use the head request to retrieve the upload offset, and then use patch again to resume from that offset. TUS is a great protocol, and we are using it as a starting point to build our new protocol. Here is our new protocol. The main difference is that we are using a client-generated token instead of a server-generated token. By using client-generated tokens, we gain two things. First, we reduce one round trip when starting an upload. Secondly, this initial upload creation procedure is compatible with a regular non-resumable upload, which means for the server that does not support resumable upload, this is just a regular post. For server that supports resumable upload, it may send an intermediate response 104 to tell the client that it supports resumable upload, so that the client is confident that it can resume it using the same head and patch requests. To recap, we are able to achieve minimum number of round trips by using client-generated tokens. We also define a feature detection mechanism so that a regular upload can be upgraded to a resumable upload. To achieve our goal of resumable uploads everywhere, this protocol can be implemented both on top of HTTP as an application layer protocol and also within HTTP libraries themselves. This allows existing adopters that already depends on resumable upload to switch to this protocol. And also eventually, everyone else can get it when the browsers and libraries themselves implement this. For advanced users, we also support a chunk upload by setting upload incomplete header field to true if the current request is not the last piece of the upload. So we have a few questions for the work group. These questions are also listed in the draft. First, I want to discuss the exact feature detection mechanism to upgrade from a regular upload to a resumable upload. So we are currently using a 104 status code to upgrade. We've also discussed using HTTP settings frame and DNS record. There are also other options that add an additional round trip, such as options requests or a well-known URI. We like 100 response because it allows us to scope this to a particular path easily, and also it is it does not incur any additional round trips.
Are you trying to advance it?
Next slide.
I can try to take control back over the
Oh, yeah.
slides if it's not working for you. I don't know what slide we're on.
Yeah. Oh, thanks. So the next question is, what about upload metadata? The current draft does not specify any way to send upload metadata. So one of the most common questions we get is, how do you send the file name in the request? The old task protocol defines upload file name, a specific header, but we think we should be using a standard HTTP header, such as content disposition. Should we mention that this explicitly in the draft? Also, there's a topic of media type. We think the upload creation procedure should send the media type of the upload itself. However, from the mailing list discussions, I believe we should be using a kind of a standard generic media type for the upload appending procedure. What would that be? I hope to we can achieve some consensus. So finally, next slide. So I want to ask about adoption. This is a two-part question. First, is this reusable upload a worthwhile problem to solve in this work group? And also, do you think this is a good approach at the starting point?
Okay, thank you for the presentation. So if you have comments on if you think this is an interesting problem to solve, you can come up. If you have questions about the details or comments about the details, you can also come up.
I will. Oh, sorry. Go ahead,
Alessandro. Oh, yeah. Sorry. Go, Mark.
Alessandro Gadini, Cloud. Oh, go ahead. No, go ahead, Mark. That's okay.
No, you go ahead.
Okay. All right. Alessandro Gadini, Cloudflare. I have a question about the client-generated token. It seems like it might be potentially a problem for a server operator, where the server side needs to be able to guarantee that the token is not reused across different clients. And also the server might want to encode the information in the token to avoid maintaining certain states. So it would be better, I think, if there was an option for the server to generate the token at the very least, or just make the token server generated.
Yes, so the token currently by default is client generated and 256-bit random data. However, if you own the client, you can do whatever. You can use your own token. You can negotiate your own data to put in the token. That is allowed by the draft.
I guess the problem arises where the server and the client are not, operated or developed by the same entity. My understanding is this proposal is to create a protocol that is interoperable between different implementations. Assuming that the server knows and can control the client might be too big of an assumption.
Yeah, makes sense. And Alessandro, just overall, I mean, are you guys interested in talking about this problem?
It seems an interesting problem. I think Lucas is involved in the design. I guess we are interested in doing things that other people are interested in doing. Like, there's not a lot of point in just us deploying some stuff that nobody's gonna use, but it seems like an interesting problem at the very least. There's potential use cases as well, like internally, where you might want to transfer big files or stuff like that.
Thanks.
Mark, it's your turn.
So Alessandro's comment kind of touches on something I wanted to talk about at a little bit of a higher layer, which is that there's a trick to play here where you want to design something and document something that's interoperable and that works out of the box, but you don't want to constrain the use of the protocol so much that you rule out, other valid uses. So, for example, the initial post to get the token conveyed, there are other ways to do that. Maybe it's a put because the client already knows where the file is going to be, for example. And so we have to be very careful about how we document it. And I'd like to have that discussion if we adopt. But then maybe kind of putting my chair hat on, when we talk about proposals like this, I think it's super important for the proponents to understand that they are giving change control to the community, that it will be owned by the IETF and that they don't have a special say, but of course they're extremely welcome to participate in the process. Likewise, for people who are not the proponents, I was glad to see the word starting point used. This is a starting point. It's not the end point, and it'll go through the normal process. And so it's important that we all have that in mind when we talk about adoption. Speaking personally, I think that there's enough interest around this and enough proven interest in this over time, thanks to efforts like TUS, that it would be good for us to adopt work in this area. And I think this is a reasonable starting point.
Thank you, Mark.
Cool. David
Skinazi, Google. So first off, thanks for this presentation. That was great. It was very clear. I think this is useful, and I do think this is a good starting point. I think there are some real and I have read the draft, and I think it is a good starting point. I think there will be some tricky questions to answer, like should we have the token generated by the client, the server? Maybe we allow both, but I'd rather we do that in the working group, so we build something that we can operate, that everyone likes. We might have some uses for this, so I'd say I strongly support adoption.
Thank you.
Cool. Alan.
Alan from Dell Meta. Yeah, thank you for your presentation and your draft. We have had our own version of this reasonable upload technology running for, I don't remember how many years, but many. And I remember this topic coming out at an HTTP workshop maybe 3 years ago or so. It's something that keeps coming up. And honestly, we probably should have published a standard about how to do it a long time ago. So I'm also happy that we're here. I think this looks like a reasonable starting point, and let's adopt it and have discussion in the working group so we can have a solution to this problem.
Yeah, thank you.
Yeah, and just looking at the chat, I'm seeing some others of Cloudflare and Microsoft echoing the same thing of we do something like this too, and it's always different. So being interoperable seems like a good thing to do, and it almost certainly will change, but as long as we are happy with, it sounds like everyone's happy with, letting the working group have some design team that's going to go actually figure out the right thing to do. And I think it'd be very useful if those people who have existing solutions in this space would kind of also present those and explain those to everyone else so we can kind of compare and learn from each other if we want to go ahead with the work. Cool. All right, any other comments, thoughts? It sounds like this is something we can take to the list of saying, hey, do we want to work on the problem, start with this, and acknowledge that it will completely change, but that's good.
Yeah. Thank you.
Okay, thanks, Goya. All right. Actually, hold on. So I'm going to present next, but I'm going to try to do it. Well, I guess anyone mind if I present from here instead of from that mic? Cool. All right. This is a document we talked about, I think, last time, where we're saying, hey, we have some use cases for geolocation, and we have some updates here. Let me reset the timer. One moment. So Dave and I talked about this based on the feedback we got, and so we revised the approach. So first of all, what is this for? Clients sometimes, not always, would like to get content that is relevant for their general location, like you want to know where pizza near you is or something else. And servers generally know your location based on your client IP address, doing a geolocation database lookup based on your IP address. This is assuming that you did not do explicit JavaScript APIs to share your precise location. So that's all happy. So what is the problem? I think mainly the problem that I've been experiencing, and I think others are sympathetic to this that I've talked to, is that these databases are often wrong or out of date or disagree between each other. Generally, servers are relying on large aggregating GeoIP services, not necessarily the databases that are the published feeds for the IP addresses directly. So they don't have authoritative data. There are cases in which different databases have different levels of supported specificity. A lot of them will turn things that are officially countrywide or statewide into specific cities, and by choosing one at random or choosing something in the middle of a region, so you can get strange results. This is particularly bad for cases where you have a privacy proxied service or some sort of VPN, like when you have an IP address that is not just a very common entry in an ISP database, but also it's also a problem for any new IPs or IPs that change location frequently. The IP maps you have for a lot of cellular networks is often really, really terribly located, and you end up just going to like where Comcast is located. Like I've been in Philadelphia while I'm in California, and that makes no sense. And recognizing that the databases are mismatched or out of sync is often just like a manual outreach process of users complaining and then someone going and asking this server to refetch their database from this provider. However, this is also an extremely fraught and dangerous area, because if you are sending the location or anything derived from your actual geolocation, you are creating a fantastic privacy foot gun. And as you know, Martin let us know last time, there's essentially no way to prevent when you move around that from just being a way to track your location. Last time we talked about how essentially when we were deriving this geohash location, it was potentially safe to do this if that location was really just derived from the IP address that you were showing anyway, because it's not anything that's new information. But that led us to a simpler proposal in which, if the problem really is that these databases are just wrong or servers don't have the right copy, the new proposal is to simply share the GeoIP database entry and associated feed with the server so that the server can know, the client has this address, it thinks it got it from here, it thinks it means this, that is a hint, do with it what you will. And so the format for this is just a structured field string, which is literally the entry that's defined for the GeoIP feeds, and it can include a pointer to the feed that owns this particular IP. So as the IETF IPs bounce around the world, you can say, hey, I'm here now, rather than worrying about which cached copy do people have on their server. From a client perspective, this it is potentially narrowly scoped today to cases where clients have a way to know what IP geomap they have. This works very well for a VPN, some sort of privacy proxy, but one could also imagine services such that when you receive your IP address from your carrier or from your ISP, they could let you know, hey, my carrier uses their carrier feed, and this is where they're putting you right now. And the client only has to share this if they want to, if they think it's useful, if they're opting in. On the server behavior, you receive this hint. There are decisions about what you can do with it. You could if you really don't care, you're just trying to show pizza near someone and you just want it to be convenient for them, you could just show them wherever they told you they were, because they're just saying, hey, I want to see pizza in Philadelphia. You could also easily filter this based on if you know the feed is a trusted feed, and essentially say if you had multiple options for how to map this IP address, that you would prefer the one that is actually authoritative for it. You could use it as a signal to refetch your feed if it mismatches what you have and you haven't fetched your feed in a week or a day or some reasonable time, so that you're not refetching constantly. And there's also potentially just a way to flag cases of new feeds coming online. So if your server starts seeing, hey, there's a bunch of IP addresses from 10% of my clients that are all coming from this new feed that I haven't heard of, maybe I should take a look at that and check if I'm mapping them to a completely wrong place. So that's the basic thing here. Just wanted to see if there's interest in working on this problem. If we think it belongs here, I'm not clear on if there's a specific other place that this belongs, but happy to hear people's thoughts. Alessandro.
Alessandro Gadini, Cloudflare. There is definitely interested in working on the problem. I haven't really thought too much about the solution specifically, but I think this is probably a good starting point. And yeah, I think we should work on this. I don't know if Httpbis is the correct place, but I'll leave that to others to decide.
Okay, thank you. Matt.
Visat. Yeah, I agree that this is an interesting problem to work on. One piece that's of particular interest to me is how to think about this in terms of satellite services, where the relationship between the IP, if you will, on the terrestrial network doesn't necessarily align with the location. So your ISP knows, but it's hard in the case of reusable IP space. It's kind of tricky to keep the databases up to date in a timely way. So yeah, I'd be definitely interested in exploring this more.
Thank you. Brad?
Brad Lassie, Google. I think this is definitely a area that we've run into and be interesting to work on. So I support working on this.
Thank you. Martin.
Martin, I'm going to disagree with everyone who's gotten up here so far and say I don't think this is quite right. One of the reasons that GeoIPs aren't such a problem for privacy is that they're very bad. And trying to fix that problem puts you exactly back in the same box you had with the geohash, unfortunately. When you have good geolocation and people start moving around, you have the ability to start tracking them. Even with the imprecise information that you have there, it depends on the populations that are in these areas. It depends on a great number of things. But what you're looking to do is improve the efficiency and efficacy of the ability to locate someone. And that has consequences for privacy that I don't think at this stage are particularly well addressed in the document.
Okay. Just to quickly respond, I think the way I've been thinking about it is, since this is reflecting the information that a well-updated server database would already have, it essentially means that the people who are really, really interested in tracking where you are will already know this information, and it's the people who are just not really paying attention and have out-of-date things that are hurting the user that will have the outdated versions. So you're not really stopping the people. You're not changing the trackers from what they're able to already see for your location.
So I'm going to interject real quick. We're running low on time for this session, but I think we gained a little bit. So I'm going to close the queue soon. Martin, could you just say whether you think that those issues could be addressed, whether we could adopt this and try and work it out, or whether you think we should not just adopt anything in this space.
I'm not going to say this is impossible, but we spent close to 10 years on this problem in this organization in the past, and came to some conclusions that were essentially, it's very, very hard to give away any geolocation information without giving it all away. And that is probably in this case somewhat maybe less of a case, because you've got this intermediate sort of step where you're going via IP addresses, and that has some inherent problems, and maybe those problems are enough to keep people private, but I don't think it's really a good basis for something that people can reason about and say, I understand the privacy properties of the system that you've produced as a result of this design. And that was something that we struggled with a lot when we were doing the GeoProof work.
Yeah. My goal would be to have a document that reduces to the same privacy properties you already have by using that IP address in the first place. But it's a question of, do we think that is possible?
Yeah, the challenge here is, of course, you're obviously looking to deploy this in the case of an anonymizing proxy. Someone's looking to obtain privacy through the use of this thing, and you've given it to them, and then potentially now you're taking it back away from them in ways that are very difficult for people to
Thank you.
understand.
I am going to close the queue now.
Then we should go.
Hi. Yeah. David Skenazy, just jumping in to respond as co-author. So I definitely think that MT understands the space much better than I do, and that this is a hard space. And I would say that if we are unable to figure out a tight privacy box, that we shouldn't publish this. But I think it makes sense to adopt it for us to work and see if we can solve this. One potential idea I have is deployment models. So in our case, speaking for Google for a minute, we're not necessarily planning on using this through our privacy proxy, but on using this to the privacy proxy. And the key thing there is we're using new technologies like private access tokens or other kinds of anonymous tokens when talking to that proxy, so that two requests over time aren't correlated. And that is really important in that, because that defeats the attack of you gave away a little bit of information here and a little bit of information there, and then through correlation, you've completely recovered all the information. If all those things are really split out, you can do that. So anyway, no, I'm not saying boom, problem solved, done, let's publish. All that to say, I think it's possible for us to reason through this, and that's it. Sorry.
Okay. Let's try to wrap up in 3 minutes. Chris
Lemons, Comcast. I don't think we can solve this problem, but I think we can make it better. And this draft appears to be a starting point for that. And I think it's useful for us to work on.
Cool. Thank you. Eric. Megan. Not that one.
We'll keep it fast. I think this is an interesting topic area. I'm not necessarily convinced that this approach is useful. I think applicability may be an important part of it, but it does seem like I have trouble coming up with cases of people who would use this on both the client and server side who aren't already at a level of maturity to take a totally different approach, or leverage some of the existing stuff like getting these feed information out of WHOIS.
Thank you. Brad?
Brad Lassie. I think working on here, we get the opinions of a bunch of folks who are certainly focused on privacy, and hopefully we can improve things over the status quo, such as potentially changing the accuracy based on population density. But the other bit is I would suggest not thinking about it as folks who have opted to use a privacy proxy, but making the ability to use a privacy proxy less painful, such that more folks will be able to adopt it and will improve privacy overall.
Okay, thank you. All right. Interest of time, let's move on. That was good
feedback. Transport off. Did you want to share your slides or do you want me to? I can do it. Boop.
Hi, everyone. David Skenazy. Today, HTTP enthusiast. So I'm going to talk about a document that was first brought to the IETF back at the Bangkok one in 2018, but that's completely been rewritten. And so now I have David Oliver, who's joined me as co-author, and we're working together on this. And please ignore the title of transport authentication. It no longer authenticates the transport. So we just haven't come up with a better one. Next slide, please. So what is our motivation? We want the client to authenticate itself to the server. It's like, okay, great, that's HTTP authentication, that already exists. On top of that, we want to use asymmetric cryptography. It's like, yep, that also already exists, HOBA, for example. But we have yet another requirement, that is, we want the server to be able to hide the fact that it requires authentication for specific resources. As my other enthusiast hat might make you guess, the main reason I care about this is mask, because there are cases where you have a web HTTP server that serves some content that doesn't want to leak the fact that it is also a mask server. Next slide, please. So why isn't this already done? The fundamental property of asymmetric cryptography, as used for something like this, is that you're using a signature and you have to sign something. So that can be many things, but conceptually it's a unique nonce because you want freshness. You don't want someone to be able to replay that authentication. So you want something that the server sends down to be signed, and you can go, okay, yep, you've signed this, and ideally you bind it to the right things, and yada, yada, yada. The problem with that is most of the scenarios that do that, you start off and say, hey, I want to use this authentication. The server says, all right, here's a nonce. Then you say, okay, I've signed it. And then the server says, go ahead. But when the server has sent you this, here's a nonce, it's just leaked that for this specific request, it requires authentication. And so boom, you lose. Next slide, please. So what do? The idea actually came from a conversation with Chris Wood back then of using a TLS key exporter. Yes, we're not trying to reinvent token binding, I promise, but it does have that in common. And the idea, the insight there is the TLS handshake contains fresh random data from both endpoints, and a key exporter pretty much creates like pseudo-random numbers from both of those random bits. And so conceptually, we use a key exporter not to create a key, but just to create a nonce that the server had input to. And then you sign that nonce so that you don't even need to transmit it. The server can decode it as well. And you solve the problem of sending a nonce without there. So Jonathan, do you want to, are you queuing up for later? Or do you have a question on this slide?
Question on this slide.
Go ahead.
So the idea of a nonce as number used once, what if I do one authentication that fails and then I try again, right? I'll use the same nonce. So like within one TLS session, you might need two nonces.
That's a good point. I'm going to have to think about that. And this is exactly why we're bringing this to this room, because there are a bunch of smart people who can tell me when I fuck up the crypto. MT, what else did I get wrong?
No, I had exactly the same thought, and I was just going through the document to refresh my memory. You don't have fresh entropy on each one of these assertions, but you could.
Okay.
So the client can provide fresh entropy each time that it provides one of these signatures, and then the problem is solved.
Sorry, can you say that a bit slower?
If the client produces fresh entropy with each one of these assertions that it makes, then there'll be no key reuse problems or replay or what have you.
Yeah.
Derive a nonce.
And so I think that solves the, I mean, I'll have to think about it more, but that sounds like it doesn't break the other properties that we want. So I think that's good. Okay, Jonathan is back. Go ahead.
I don't even know that you need fresh entropy. Couldn't you just use a counter? Like the client says, this is attempt 1, this is attempt 2.
Yeah, I think that's what MT was saying.
Yes. Yes.
Yeah. All right, cool. Next slide, please. Here's the way the wire encoding looks today. You send the signature, because you send the algorithm that you used for the signature, and there's a username in there because we figured that could be useful for the server to look up in its database of public keys. And yeah, whatever, like I'm sure we can completely backshed that if people care. Next slide, please. Note about intermediaries is obviously this is tied to the underlying TLS handshake. So it works over HTTPS with TLS or quick, but it doesn't work through intermediaries. And so we have a section on that about, and that's something that's kind of commonly done today, where the intermediary, if it's a reverse proxy, can be responsible for checking the authentication, and then in a way that it has that's trusted between itself and the server behind it can say, yep, it's this user and I've checked their authentication. And we have it in such a way that if the intermediary accidentally just forwards these along instead of working on them, the other one won't be able to validate, things will break, all is good, unless I messed that up too, but probably that's good. All right, next slide. We have another independent implementation by the Guardian project that Dave works on and so we're talking about having this like in various open source projects. We figure it makes sense for us to have a place to discuss this. That would be nice. Even just from the conversation today, I'm realizing that I already learned something and like probably saved a few toes in the process. So we'd love to hear, are folks interested in this? Do you also think this is useful? Is this the right place to talk about this or not? What are all your thoughts? And I'll open up the mic queue. Ooh, Mark.
So speaking just as an individual, I think this is an interesting area of work. I think it's possibly important even. I would be so much more comfortable if the draft were positioned in terms of, and the initial discussion of the working group were positioned in terms of what properties it has rather than what the solution is. That word transport is not helping you right now.
Sorry, can you repeat the last sentence?
I just said the word transport is not helping you right now.
Yes, no, that, again, we need to rename it. I'm totally with you. Or did I mishear what he said?
No, it's just focus the name or like the solution on like hidden client asymmetric client authentication.
No, absolutely happy to. I just wrote this the day of the draft deadline and didn't have the time to figure out a better name, and I figured everyone would have opinions on that. So, all right, thanks, Alessandro.
Alessandro Ghedini, Cloudflare. This sort of reminds me of the ACP2 certificate frame. Any thoughts on that?
In terms of how entangled it is with TLS, I get you, but
So I haven't implemented the certificate frame myself, but from this one, it felt like a much easier lift to get it to work, to implement it into an existing code base?
So there's two main differences, I guess. One is that's a frame. This is not a frame. So there's different use cases that having like a frame covers, like, you know, post request authentication or something if you want to. The other is the certificate frame uses certificates like X509 certificates. There's probably ways to use raw public keys for that as well. It seems it seems like a certificate type solution, certificate frame type solution is more broadly useful, not just for client authentication, but, you know.
So my concern with using a frame is that, unfortunately, on the internet today, HTTP2 servers just explode if you send them a frame that they don't know about, which they're supposed to ignore. I get that here it's not absolutely critical because you're sending this to a server that you trust, but like I don't love that. Also, it prevents being able to use it on H1. And when it comes to certificates, if I can stay as far away from X509 as I can, I would very much prefer that.
Right. I mean, there's probably ways to define certificate frame in such a way that you don't actually require a certificate, but, you know.
Awesome. Thank you. Alex.
Alex Tranowski, Google. So I have two comments here. The first of which is that this absolutely breaks in the presence of intermediaries, because the thing you'll be...
Sorry, slower, man.
This breaks in the presence of intermediaries, like if you have a reverse proxy, because the exporter will be running on the reverse proxy and not the target. So this is only generally applicable if we can fix that.
So did you read the section about that in the draft?
I didn't get there, but nonetheless, that already means that I think this is a foot gun waiting to happen in the current formulation, which is what gets me to the second part, which is that this authenticates the channel, not the session, which means that we have additional cryptography problems that we need to think about when you go to H2 or H3. As you may know, I designed something recently that used TLS exporters for Google internally to do a binding between the X509 presented certificate and a Google internal certificate. And I think that there is certainly a place where TLS channel exporters are a fit, but I think we need to think about if we're trying to authenticate the channel or the session here before we can make progress.
Sure. I mean, that's something that I'm happy to discuss. Yeah. All right. Well, thanks, everyone. Question for the chairs. What would you expect from the authors in terms of next steps?
It sounds like we'd want at least like another version of the draft that reframes it more with the authentication goals up front rather than the transport-ish bits, and then we talk more and have people chime in on the list.
Thank you. That's good feedback. Thanks, everyone, for your time.
Okie dokie. Metadata.
Hello. Can
Take
everybody
transport out of the title. Hi, Bence. Go ahead.
Hello. Can everybody hear me?
We can.
And this is the button I have to push to control the slides.
Okay, yes. You can now control things.
Amazing. Hi, my name is Ben Sabeki from Google, and I'm here to talk to you briefly about a proposed new frame for HTTP2 and HTTP3 that we call metadata. So metadata is some information about the request-response exchange or the whole connection that doesn't modify HTTP semantics. And we propose that this is formed as a list of key value pairs that are not HTTP fields. Example usage for this would be logging or other diagnostics. It could be communicating RTT as seen from an endpoint, or CPU usage that could then be used for load balancing by the other end, or other internal use cases. So this is not part of the actual HTTP message itself, but it's about it. That's why it's meta. Currently, we have a use case for it, and we have it widely deployed over HTTP2 in the form of a new frame. And we are working on the HTTP3 implementation, which we do need in order to be able to deploy HTTP3 internally between our proxies. Metadata frames are negotiated via a setting. The way we chose to encode the list of key value pairs is HPAC for HTTP2, and we were planning to use QPAC for HTTP3, with the caveat that we are not using the dynamic table at all. And the reason for that is that for our particular use case, the keys are typically short and the values tend to be unique. So we don't anticipate a lot of compression gain from using the dynamic table. And we did restrict the use of HPAC and would restrict the use of QPAC to not use the dynamic table at all. We are just using HPAC for convenience because it's something that we have at hand, and we get a little, maybe a little gain with Huffman encoding. Metadata frames have advantages over header and trailer sections. One of them is that they can be sent at any point during the exchange. They can be sent in either direction, just like headers or trailers. There can be multiple of them. There's no limit on the number of metadata blocks that can be communicated. And also there's no restrictions on the values that each character can take in the key or the value of the list of key value pairs in the metadata block. Notice I'm talking about metadata blocks and not frames, because in H2 there's a frame limit, and we of course obey that. So a single metadata block can be fragmented across multiple HTTP2 metadata frames. Also, we allow metadata blocks to be sent on stream 0 for HTTP2 or the control stream or HTTP3 to convey information that pertains to the entire connection instead of a single request response exchange. And this is all I wanted to share. And also I wanted to say thank you for the valuable feedback that we have received throughout the past week on the mailing list. Questions?
Great. Thank you. I got in queue as an individual here. Having yet another opaque blob that you can just transport through here is concerning and raises a few alarms. It seems to me that the mechanism that we have that allows you to do this, like we already have frames. Essentially, it's just like a frame inside of a frame to some degree. I completely understand how it makes very good sense within proprietary deployments where you're just trying to say, let's stuff things in and see what makes sense, what is useful. What I would be interested in hearing is, of the things that you do inside metadata that have become useful in Google, would there be specific frame types that you would like to define out of those? You gave some examples of what you would want to put in there. Nothing stops us from defining lots of more frame types. And so if they are useful frames, we could define those there instead of a generic metadata where you just stuff another registry inside of it. That's all. Martin.
I was wondering if you'd get a response. So, Martin Thompson, thanks for the presentation, Vince. It's always great getting an insight into how the internals of these systems work. But the only thing that I heard from your presentation was that Google has a bunch of proprietary extensions to HTTP2 and HTTP3. I don't see any value in having some way to gather them all up into the same bucket. I certainly don't see any way in which that would promote interoperability if the things that fit into that bucket are different in Google's deployment and different in someone else's deployment. If there are things that you are doing here that you think is useful for someone to use in other settings, I would suggest, like Tommy just said, a frame for defining the exchange of that information, whether it be on stream 0 or I should say a control stream or a request stream, or yes. would be really interesting. And so timestamps and details of CPU utilization or whatever it is, that would be interesting to have a discussion about. But an entirely generic bucket, I don't think is especially interesting in terms of standardization.
I really appreciate that feedback, and unfortunately there's nothing that we would feel comfortable talking about externally that is a particular use case. the way I think about this is that the purpose of this exercise of writing up this draft and bringing it here and having this conversation here in this working group is to kind of gauge interest and see if anyone can think of outside Google, like, hey, we are doing this thing, or we meant to do this thing, and using metadata frame or a more specific frame type would be helpful. And if no one jumps up and says, we really want this, that's important information for us. Us as a working group, I mean. And the perfectly reasonable outcome. Biren, do you have anything to add?
No, I think I agree 100%. Yeah, and thank you also again for the useful feedback on the mailing list.
All right. We have just a minute left on the clock. Lucas, Alan, and David are in queue. Lucas.
So, hello. Yeah, thanks for bringing this to mailing list. Appreciate there's walls of text I put on there. I think it's a good chat. I'm aware of use cases of people trying to do stuff where carrying sidecar data alongside with requests is really useful, and they've struggled trying to puzzle how to do this. Maybe even just using their own connect method and hacking it and creating like a weird chunking format thing, where actually like H2 and H3 framing would have been a much neater solution. And I think Capsule kind of goes towards that. I'm not advocating we should use capsules. There's like a whole like spectrum of what to do here. But the most generic thing, I'll echo that. I just think it opens up a can of worms for developers who aren't us, that they'll see it and think, oh, I can start sending headers and do whatever I like, and it's going to work somehow.
Alan Frindell, I will sort of offer maybe a counterpoint to what Martin and Tommy push back on the generic nature, in that HTTP header fields and trailer fields are already generic. That's to the API. That's one of the things that makes HTTP really flexible, is you can just stick your own headers in there and you don't need to change implementations to do so. So having a mechanism like this does provide some value. And I think there are cases we've had internally also oftentimes communicating sort of like timing data maybe, or other like metadata or stats in the middle, like while we're transmitting a long running response or something has come up. I believe I even told somebody once to use push. So let me use that dirty word to like generate more interest in something better.
Define a timing frame.
David Skenazy, I'll be very quick. No, this is HTTP, sorry. I'm the one who encouraged Benson and Biren to come and talk to the IETF, because they were working on this and, you know, using it. We're going to use it for very real things like Google. We're going to be putting it in, like, probably, I can't commit to future plans. We're going to probably be putting it into the Envoy HTTP proxy, which is very widely used outside of Google. And so my thought was, let's bring it to the IETF. Let's see if people tell us no one else has a use for this, then, you know, we just ask for the code point and we're done. But if other people think this is useful or can improve it, we're very willing to take feedback and to work with the IETF. So we thought it would be interesting. And that's why we're super willing to hear any feedback and see what other use cases people have.
So I inserted myself briefly using my awesome privileges as chair, just to respond to something that Alan said, which is, you know, if we do want to add something like this, I think we need to look at it as a change in the developer visible signature of HTTP. You know, right now we've got these, you know, request response, messages, headers, body. We could add a new construct to all of that. And we've tried that before with things like server push. But if we do that, it needs to be something that's really deliberate and I think really well thought out, because we've also, frankly, failed a lot when we've tried to change the wire signature of HTTP or the developer signature of HTTP with even things like pipelining that are more incremental. So it's not a hard no. It's just there be dragons.
All right. Thank you very much.
All right. Thank you. With that, we are 3 minutes over time, but I think this has been a very productive session, and I'm happy that we got through all of the content that we had here. Mark,
do we have any next steps on this
It
last
sounds
one
like
that
we
you
need
wanna
more
conclude
discussion
with?
on it, and maybe use cases. Yeah.
Agreed.
All right.
All right. Thank you all. Thank you, remote people, and Mark for joining in. And have a good rest of your
Thank you,
IETF,
Tommy.
everyone.
Could do this from my comfort of my home.
See you next time. Bye-bye.